Hello and welcome into the supplemental video for solving trig equations. Again, this doesn't specifically tie to a lesson. We did our trig equation lesson, but this is the one I want to go through the different problems that you guys had in class and actually how to work them. I know there was some confusion on some of the problems. So I just want to go through them, explain them to you, explain why the answers are formatted maybe the way they are. So let's look at those problems. So the first 6 problems said find all the solutions. So if you watch the content video, if you watch the example video, you know when it says find all the solutions, that there's essentially an infinite number of solutions to these trig problems, right? Because let's say my answer is 0. Well, I can also go around the circle 2 pi, and that's a solution. And go around again 4 pi, go around again 6 pi, etc. So whenever I have all solutions, this means either plus 2 pi k, if it's cosine, sine, secant, or cosecant, or it's plus pi k if it's tangent or cotangent. So if you give me an answer that doesn't have that multiplier on it, it's wrong. It's already wrong. And you're basically telling me, hey, George, I don't know what I'm doing. Go ahead and start taking off points because I don't know what it means when it says all solutions. That's what it means. It means you need to have that multiplier. Daisy, stop. Hey. Now, the last two we're going to look at will give us an interval on which the answers have to fall, and then that's a little bit different. Daisy, stop. All right, so the first one we had was what? It said the square root of 2 times sine of theta plus 1 is 0. So we have to get down to the trig function. So we do what? We first subtract 1. So I get square root of 2 sine of theta is negative 1. Divide everything by square root of 2 means sine of theta is negative 1 over root 2. So if I rationalize that so that it looks like what I'm used to seeing, that becomes negative root 2 over 2. So now to solve these, the first thing I need to do is say where on the entire unit circle is sine equal to negative root 2 over 2. And that's when theta is 5 pi over 4 and theta is 7 pi over 4. And so if this said just what are the answers on 0 to 2 pi, that's it, I'm done. But it didn't. It said find all the solutions, meaning I need to add 2 pi k to both of these. So that would be my answer. The second problem said 2 cosine of theta minus 1 is 0. So it's essentially like the last problem. It's just instead of a square root of 2, I just have a 2. But I'm going to add 1 to both sides. So I get 2 cosine of theta is 1. Divide by 2. So cosine of theta is positive half. So again, where on the entire unit circle is cosine positive half? That's pi over 3 and 5 pi over 3. But because I want all the solutions, I have to add 2 pi k to both. Number 3, we had sine squared of theta equals 6 sine of theta plus 7. So this is similar. If you want to think of this, this is like x squared equals 6x plus 7. So I have to do what? I have to get everything to the left side so I have a quadratic, and then I can factor and use zero property rule. So I'm going to do the same thing here, sine squared of theta. So minus 6 theta and minus 7. 6 sine of theta minus 7 is 0. And now I can factor this. And again, if you want to work with x's instead, so if you factor this, we get what? X minus 7, x plus 1. So it's the same idea here, it's just sine. So sine of theta minus 7, sine of theta plus 1. And now by zero property rule, sine of theta minus 7 is 0. Sine of theta plus 1 is 0. So sine of theta is 7. Well, where on the unit circle is sine equal to 7? Nowhere. So this whole one doesn't give me any solution to it. But I can't write no solution in my solutions because either I have a solution or I don't. So from this one, I get sine of theta is negative 1. Well, where on the whole unit circle is sine of theta negative 1? Only at 3 pi over 2. So yes, this one gave me no solution, but I can't put no solution in my answers because I do have a solution. It's 3 pi over 2. And all the solutions is when I add 2 pi k because I had the sine function. So this would be your answer for number 3. You can't put no solution. It's like if I said I have 0 coins in my pocket and I have 3 coins in my pocket. Well, that's not possible. You can't have 0 and 3. You have to have 0 or 3. So same thing here. You can't have no solution and a solution. You just have a solution. That's it. Number 4, 3 tangent to the third theta equals tangent of theta. So first thing, subtract tangent of theta from both sides. So we get 3 tangent third theta minus tangent of theta is 0. So factor tangent of theta out. So I get 3 tangent squared of theta minus 1 is 0. And so what a lot of you did at this point, you're like, okay, don't worry about this guy. Well, no, you still have to worry about him. Same as if I have like 2x squared plus x equals 0. If I factor out an x and I get 2x plus 1 is 0, I can't just say, well, forget about this guy because he's out in front. He doesn't matter anymore. No, your basic algebra rules still apply. You still have this tangent of theta in front being multiplied by this. So you need to set that equal to 0 and set what's inside equal to 0. Again, zero property rule. They both have to be 0. So now, where on the unit circle is tangent equal to 0? Well, that's at 0 and at pi. And so plus pi k, because it's the tangent function. Now again, these two answers are essentially the same, because if I have 0 plus pi k, if k is 1, I get what? Pi. So I've kind of doubled up the answers, but like I told you guys, don't worry about that. Like I don't care if you double up the answers, just make sure you have all the answers. And then this one, if I add 1, I get 3 tangent squared equals 1. So divide by 3. Tangent squared of theta is 1/3. So take the square root. So I get tangent of theta is plus or minus square root of 1/3, which is plus or minus root 3 over 3 if I simplify and rationalize. So that's what? So first of all, I have these two guys over here. And for this one, root 3 over 3, that's all my values that have 6 in the denominator. So pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. And again, I know there's doubling up. I'm not worried about that. We're going to put pi k on all of these. So that's all the answers. Again, there's some doubling up. I'm not worried about that. Don't worry about outthinking the room. Make sure you have all the answers present. So that's your answer for number 4. Number 5. We have sine of theta times cosine of theta minus 9 times sine of theta equals 0. So the only thing I can do here, it's already set to 0, so I don't have to move anything around. Just factor out a sine of theta. And when I do that, I get cosine of theta minus 9. And now do zero property rule again. So sine of theta is 0. Cosine of theta minus 9 is 0. So let's work this one. Cosine of theta is 9. Where is cosine of theta equal to 9? Nowhere. So that does not provide a solution for me. So I'm just over here. Where is sine equal to 0? Well, that's when theta is either 0 or pi. So add your multiplier because we want all solutions. That would be your answer for number 5. And then number 6, we had 2 cosine squared theta minus sine of theta is 1. So in this situation, I don't have the same trig function. I can't factor anything out. Ah, man, I'm stuck. If only there was something George told us on the second day of class, if we ever get stuck, we should do. That's right, the Holy Grail. So I'm going to substitute cosine squared as 1 minus sine squared of theta. Distribute your 2. So you have 2 minus 2 sine squared theta minus sine of theta is 1. So rewrite this, negative 2 sine squared theta minus sine of theta plus 2 equals 1. So let's subtract 1 from both sides. Negative 2 sine squared theta minus sine of theta plus 1 is 0. And again, to make this easier to factor, I'm going to multiply the entire equation, both sides, by negative 1. So I get 2 sine squared theta plus sine of theta minus 1 is 0. And I think this might have been one of the problems from the example video. But I can factor this as 2 sine of theta and sine of theta, and then 1 and 1. Because I need the plus, I'm going to put the plus with this guy. So now we get 2 sine of theta minus 1 is 0. So 2 sine of theta is 1. So sine of theta is 1/2. And from this one, sine of theta plus 1 is 0. So sine of theta is negative 1. So where does this happen? Well, where is sine positive half? That's pi over 6 and 5 pi over 6. And where is sine negative 1? That's 3 pi over 2. Because I want all solutions, I need plus 2 pi k on all of these. So that was the first 6. On those, it said find all the solutions. Now, the last 2, it said use the double angle formula to solve the equation on the interval 0 to 2 pi. 0's included, 2 pi is not. So if you put plus 2 pi k in your answer, it's like putting up a big sign for me that says, George, I still don't know what I'm doing because it's telling me write it on the interval 0 to 2 pi, and I have no idea what that means. So I'm just going to put 2 pi k on there because I've seen it before. No, that's not what it means. It means your answer has to be between 0 and 2 pi. So if you put plus 2 pi k, you're way outside of 2 pi. So you just want the answers that are on the unit circle for these specific questions. So number 7, we had cosine of 2 theta plus 5 cosine of theta equals 6. So subtract 6 from both sides. So I have 5 cosine of theta minus 6 equals 0. And now here, I'm going to use my double angle formula. Remember, when we see this 2, I know in the problem it told us, oh, use substitution for half or double angles to solve these. Well, even if it didn't say that, when I see that 2, it means, oh, double angle. And so if I substitute it, I have 3 different choices to pick from, but because I have a cosine here already, I want the one that has cosine in it. So 2 cosine squared theta minus 1. So combine my like terms, I have 2 cosine squared theta plus 5 cosine theta. Negative 6 minus 1 is negative 7. So factor this. This can only be 2 cosine of theta and cosine of theta. And 7 can only be 7 and 1. Well, obviously 7 minus 2 is 5, so I need to keep the 2 and the 7 separate. Because I want it to be plus, I'm going to put the plus with the 7 minus with the 1. So this gives me 2 cosine squared plus 7 minus 2 is plus 5, and 7 times negative 1 is negative 7. So 2 cosine of theta. 2 cosine of theta plus 7 equals 0. Cosine of theta minus 1 is 0. So 2 cosine of cosine of theta is negative 7. Divide by 2. Cosine of theta is negative 7 halves. 7 halves is like 3.5, which is way bigger than 1. So again, this one doesn't give me any solution. So I'm just left with this guy. Cosine of theta is equal to 1. Where on the unit circle between 0 and 2 pi is theta equal to 1? That's when theta is 0 radians. Yes, it's also 2 pi, but it told us 0 up to 2 pi, but not including 2 pi. So your answer is only 0. That's it. No 2 pi k, no 2 pi, nothing, just 0. And then 8, we had cosine of 2 pi, cosine of 2 theta plus sine squared of theta is equal to 0. So again, I have plus sine squared theta here. I have a double angle. I can choose any of the 3 that I want. I could choose the 1 minus 2 sine squared theta, but one of the other options is what? Cosine squared theta minus sine squared theta. So what happens to these two? They just cancel out. Sine squared minus sine squared is gone. So I have cosine squared theta is equal to 0. Take square root. Cosine of theta is 0. Where is cosine on the unit circle equal to 0? That's when theta is pi over 2 and 3 pi over 2. And that is it. Those are the only 2 values between 0 and 2 pi where theta is 0. So that is my final answer. That is as far as I go with it. So hopefully that helped you. Hopefully, pointed out. I know I may have sounded upset. I wasn't upset. It's just you guys are okay with the trig part of it. You're just getting tripped up on the basic algebra. And so at some point you have to make the decision. Either I'm going to go fix these algebra issues I have, or I'm just going to continue to really struggle on these problems. And I'd rather you don't struggle on these problems. I want you guys to get all the points on these things. So that's it. Again, hopefully that helped, and we'll see you in class.